This video in a few minutes goes over the answers to quiz 3 for the basic science class. This is very straightforward. There are no problems here. It is just basically definitions and a couple of concepts. So the first one says blank is an area of the lodestone where the magnetism is concentrated. That's called a pole. There's generally on a magnet there's a north pole and a south pole, but the concentration of magnetism is at the poles. Number 2, the region around the magnet in which other objects are affected is called the field, magnetic field. And number 3 in this tells you how you indicate the magnetic field, and that is blank are imaginary lines that indicate the magnetic effect. And these are called lines of flux. Lines of flux. Now, if you put magnetic lines of flux or magnetic flux, I would give you credit for it, but you had to have the word flux in there as part of the answer. Blank is a group of aligned atoms that have a magnetic field, and this is where magnetism comes from, and this is called a domain. So when these line up, when these domains line up, then you have a magnetic field. The temperature at which a magnet loses its magnetism is called the Curie, like Madame Curie, point. I don't know if it's named after her because I don't recall her doing experiments in the area of magnetism, but the Curie point is the name of that temperature. The strength of an electromagnetic magnet is based on two things. The first one is the number of turns. Sorry about that. The number of turns. And I'll show you what that means in a second. And then secondly, it's the current, or the square. Some people put the actual square of the current, which is correct. So if you have, let's say you have a nail, this is an iron nail, and you put wire around it like that, the strength that this magnet is the generated magnet by this current through this wire is going to be related to the number of turns that this has around this nail, and the more turns that you have, the stronger the magnet. And it's also going to be related to the current, which is the amount of electrical charge that moves through here. The current is the actual number of electrons that pass through this wire. The greater the current, the more electrons that pass through the wire. Blank is the angle between the compass needle and true north. That's called the angle of declination. Declination. I don't know if I spelled that right, but that is the angle. So for example, if this is north and you're standing in such a way there's an angle between you, where you are, and true north, there's an angle that this needle is going to point off slightly. I've exaggerated it here. This angle right here is called the angle of declination. Now, because the Earth, the actual magnetic field is not on the surface, but under the surface, a needle can actually point down toward the Earth, and that type of needle is called a dipping needle. Dipping needle. All of these answers, by the way, are in your book. There were no trick or surprise questions here. This last one talks about the extent of the magnetic field. This is called the magnetosphere. And again, I'm not going to swear by the spelling here, but that is the total extent of the magnetic field of a planet or body. And so once you're inside the magnetosphere, so if you have the Earth, for example, like this, the magnetic field extends out a certain amount. And this border, this amount, where this extends to is called the magnetosphere. Give 3 ways a piece of iron can be magnetized. First of all, by direct contact or conduction. So if you lay an iron piece of iron on top of a magnet, it becomes magnetized by induction. And as it turns out, if you lay it close to a magnet, by induction, it can also become magnetized. And then lastly, as I said up here, by passing a current or electricity through it, you can induce an electric field or a magnetic field as well. State the law of magnetic poles. Like poles repel and opposite poles attract. That's the law of magnetic field or magnetic poles. Like poles, so two north poles or two south poles are going to repel each other, but opposite poles will attract each other.